Finding the perimeter or circumference around circles, and then the area requires us to use the formulas that in many cases we learned last year. What we're going to do this year is extend it a little bit to dealing with composite shapes. So to remind you again, circumference or perimeter of a circle is either pi times diameter or 2 times pi times radius, remembering that radius is half of your diameter, or diameter is twice your radius. So those two are identical formulas. I personally prefer to work with this second one because when I come to find the area, I'm going to be working with the radius. So if that's just the thing I look for, that's the thing I remember. However, we're extending it this year. And the extension this year is to look at when you don't have a full circle, like our example here. And so you actually have to work with finding, for example, this distance around here, what we call the arc length. And to find that arc length, you have to find the ratio of the whole revolution. So we take theta, which is this angle here, and we put it over a full revolution of 360 degrees to find that section. So the arc length, which is just the outside, is theta over 360 times 2 pi r, this circumference formula. However, if we're finding the perimeter of a sector, you've got to remember you're finding the distance all the way around, which includes these two radiuses, or r and r. Remember to break your shape up to look at how many lengths you're finding. In this case, you want to make sure you've got 3. So it's the arc length plus the radius plus the radius. Similarly, when it comes to the area, theta again, or the angle, over 360 times the whole thing. So it's like we're finding that fraction. So make sure you're aware of these formulas. It's a slight extension, but sometimes it throws us. So make sure you understand what it's looking for. Let's actually have a look at a more complicated example. So, if my mouse will respond, we have here 2 questions where we need to find the perimeter of these shapes. Sorry, my mouse is being painful. So, I've got 2 shapes that could look quite complicated, but let's break them down and make them a little bit easier. With this first shape, for example, it's like I've got a rectangle and a quarter of a circle. But I want to use the formula I'm teaching you to do this. So to begin with, I might do question 1, perimeter. When I have a look, it looks like I've got 1, 2, 3, 4 sides. So I want to add 4 numbers together. The first 3 are pretty straightforward, 15, 7 and 22. So we can just write those up. It's this 4th one that's going to throw us. Now I said it's a quarter, but I want you to use that arc length formula. So it's theta over 360 times 2 pi r. Remembering that is the circumference. So we're finding that fraction of the circumference. When I then substitute, I need to be aware that this angle here is 90 degrees. Now I could simplify that to a quarter, but at the moment, just do it this way because then you're dealing with the exact angle. Now I do need somebody to type this into a calculator for me and to give me the answer that you come up with.
So you did the radius as well?
Oh yes, that one helped, thank you. And the radius, oh I need to work that out, sorry I forgot about that. 22 minus 15 will give me a radius of 7. Oh, it's already there for you. Okay, so hopefully somebody can type that in now. It's 54.99, so I'm just going to round it to that. Metres to 1 decimal place. All right? Now, the second question asks me to find the area. Let's move a little bit quicker. So my area is going to be two shapes, a quarter of a circle and the rectangle. So it's going to be base times height plus theta over 360 times pi r squared. So I hope someone's got a calculator out ready to go. My base is 15. I can see that by looking at the top here and just bringing it down to my base. Plus theta again is 90 over 360 times pi times my r squared. Alright, hopefully someone's...
And 43.5.
Yep, 0.5. And I need to remember my units. We now talk about units as square metres. And I'm going to write to 1 decimal place after that. Notice how I've broken it down. Two different shapes, just add them, work it out and add them together. Why don't we have a look at question 2? This looks more complicated. It looks quite detailed. But actually, when you think about it, it shouldn't be too hard. It's really two circles, and all you do is you work out the outside one, take away the inside one for the area. But when we come to perimeter, we have to work out the outside and the inside. Now, I am going to use the pi d formula because I can see that I've got diameter straight away from both of them. So my perimeter is going to be equal to pi d plus pi d, because I'm doing both circles together. In this case, it's pi times 12 plus pi times 30. Somebody hopefully typing that into a calculator for me. I'm quickly in my head working out 3 times 12 is 36, 3 times 30 is 90, so my answer should be around 126. What's after the point
131.94.
94? I'm going to say 131.9 metres to 1 decimal place. That one's pretty quick, isn't it? Once you write the formula, the answer's easy. For the area, I'm going to do the area of the outside one minus the area of the inside one. So even if I was to write, I could write it up like this, A1 minus A2, where this is A1 and this is A2. The thing I need to be careful with here, both of them are given as diameters. I need to work out my radius. So my bigger circle, 30 is the diameter, that makes the radius, what's half of 30? 15. So we're going to have pi r squared minus pi r squared in both cases. Pi times 15 squared minus, what's half of 12? Great. Pi times 6 squared. All I need to do now is type that into my calculator. And what answer do I get? You're all copying down really well, that's good. We should have a calculator out somewhere.
593.8.
Is that right? Definitely done minus? Yep, okay. Sorry, I'm just trying to do the calculation. Square metres to 1 decimal place. So I'm just thinking, yeah, 225, 6, 75. Yes, actually, that sounds good. Thank you. Well done. That's how we get that answer. So with these questions, logically break them down. All right? Logically, just work through one shape at a time and find your answer. When you break it down, there shouldn't be too hard.